I don't know. If it's only
So one carbon is there, na? Tarini, one, ha. So
methane,
one carbon, what with the
methyl
word we use?
oxide.
Ha, ha. That is meth, ha, ha. No, meth, then single bond, in. Okay. And then COOH group is what is that? Oic acid. So methanoic acid. Is it okay?
Yeah.
Yes, yeah, no.
Yes.
Now go for the second one. Here is one. This is two. So two carbon is eighth.
Ethanoic
Yes, yeah,
acid.
no. Ah, ethanoic acid. This is the ethanoic acid.
Then
Here you can
propanoic
see.
acid.
Now, what about this one? What propanoic acid? This is what is the propanoic acid. Now, that is what, if you read out little bit more things, so you will be able to know some ideas. Carboxylic acid, as their name suggests, from acidic solution. Okay, when dissolve in water, you can look at one of their reaction in the practical on the next page. What is there? See the practical, what you can do in the home also. Carboxylic acid have the typical reaction of all acid. For example, reaction with the metal carbonate form salt. So what is the, this is the metal carbonate. Sodium carbonate is metal carbonate. What is forming? This is the salt. This is the salt. Again they are saying water. Here is the water and carbon dioxide. This is the CO2. So if you are treating the carboxylic acid with the sodium carbonate, it is going to give salt, water, and CO2. So what we are going to do, we are going to write the equation. Where we can write the equation? Let us see. I am writing here. So CH3, C double bond O, here is the OH. Now we are having the another things, Na2CO3. This is what, if you are knowing this compound, this is what is called sodium carbonate. Sodium carbonate, right? Carbonate, NaT. Here is the, this is the acetic acid, or you can say ethanoic acid. Ethanoic acid. Now this is what also called sodium carbonate washing soda, that you can do in your home. So what it is going to give here, you see. So they are saying that is, it is going to give no, sodium salt of carboxylic acid. So here you see this molecule here is going to combine with the sodium like that. Okay, you need to take two. So here you see two molecule of CH3. Here no need to mention like that. Okay, here you see how many molecules are there. This is the two molecule CH3. Here is COONA. Then you see how many hydrogen are there. Here multiply by 2. 2 hydrogen and here 3 oxygen are there. So you take out 1 oxygen, 2 hydrogen. So it is going to be H2O. And then finally what is left? That is CO2. This is. Can you understand the equation?
Yeah.
Okay. Now see this one. Why a carboxylic acid is called weak acid? Can you tell me why it is called weak acid? Yes, Tarni. Weak acid means if you are dissolving in water, na CH3COOH, you dissolve in the water. So what you are going to get? You are going to get the iron. Okay. Here you are going to get the iron. So this iron will be what? CH3COO minus plus H plus. But this number is very less ionized. It is going to be ionized, very less ionized. So what we can say, students, so weak acid. So weak acid. If it is ionized very less, student, Tarni, so it is going to be weak acid, right? So acetic acid is weak acid because it is less ionized. Here you see. Uh, Here they are saying carboxylic acid are weak acid as opposed to strong acid such as hydrochloric acid. Okay, now reason they are saying, reason here you see, the what are the real acid must dissolve in water before they show their acidic properties. This is because in water all acid ionize split up. Okay, this is splitting now in two part. Split up. Their molecule is split up to form the H plus ion. Here it is splitting the H plus ion and negative ion. This is the what is the acetate ion, negative ion. It is the H plus ion that all acidic solution have in common. For example, hydrochloric acid, the HCl molecule, all ionize in water. So they are saying why HCl is strong acid, because it all ionizing in water 100%, but it is ionizing how much? How much? It ionize less. You know, this ionizing very less. That is why the this is weak acid. Are you getting this one? This is
Not really.
ionizing less than 100%. Is it okay?
No. So can I
Okay.
read? Should I read the entire thing?
Okay. Better you did. Okay. Hmm.
You will see in the practical on the next page how carbon dioxide gas is given off more slowly when a metal carbonate reacts with a carboxylic acid as compared with hydrochloric acid
Hmm.
of
Hmm.
the same concentration. Carboxylic acids are called weak acids as opposed to strong acids such as hydrochloric acid.
Hmm.
pH of a 1 mole by dm cube solution of hydrochloric acid, a strong acid, is 1, yet a 1 mole by dm cube solution of ethanoic acid, a weak acid, has a pH of only 2.9.
Hmm.
The
Hmm.
solution of ethanoic acid is not as acidic even though the two solutions have same concentration. Why is this? Acids must dissolve in water before they show their acidic properties. This is all because in water all acids ionize, split up, their molecules split up to form H plus ions and negative ions. It is H plus ions that all acidic solutions have in common. For example, in hydrochloric acid, the HCl molecules all ionize in water.
Okay.
HCl, okay.
Hmm. Okay. Okay. Let's see. So, because you are facing the difficulties, let us take some other notes. Hmm. Yeah. Right. What I am saying, this one, I am saying if you talk about the CH3COOH, right? So here, if you are treating with the Na2CO3, so they are saying that is CH3COONA plus H2O plus CO2. This CO2 is very large. This is large. Okay, two molecule you have taken. Suppose you are taking that is CH3 COOH plus you will take the HCl, right? So it is going to give oh sorry here HCl you take, you are supposed to take HCl, but same time you are taking Na2CO3. So what the salt you are going to get? NaCl, two molecule NaCl, plus it is going to be H2O plus CO2. CO2 giving, that is the first case. If you see the first case here, whatever the first case, that is because it is the very small amount, and here is the large amount. Why the large amount CO2 produce? Because reason, because this HCl is strong acid. This is the strong acid. Okay, and here is this is going to be weak acid. Weak acid. So that is why CO2 evolve is the small quantity in case of acetic acid, but large CO2 because of the HCl is strong. Second, this is the first reason. Here is what we study. This is the reason number one. Okay, reason number one. Now, second factor, the factor say they said, if you take the concentration, what concentration? Concentration 0.1. Okay, mole per decimeter cube, dm cube. So that is pH here. If you talk about the pH of acetic acid, CH3COOH, it is something 2.03. But if you are talking about pH of HCl, it is going to be 1. No, it is going to be around 1. So here you see pH scale. Do you know pH scale? Somewhere it is 7. Here 0, 1, 2, 3, 4, 5, 6. Here is 8, 9, 10, 11, 12, 13, and 14. So here if you go this side, this is a strong base. This is a strong base. If you go back side, so that is going to be a strong acid. So which is more strong acid, pH 1 or the pH 2.3? Yes, Sarni.
Which is strong acid is 1.
1, because this side lesser the pH value is stronger the acid. Now because you are facing the problem, read out again this paragraph. Here you see they are saying if you are taking the pH of 0.1 mole per decimeter cube solution of hydrochloric acid. So here they are saying, and at 0. Mole ethanoic acid also weak acid. Here pH 2.9. Okay. And if you are talking about pH of hydrochloric, it is 1. So which one is strong acid? This is obviously HCl. Yes or no?
Yes.
Understood.
Yeah.
Second one, the first reason you see they are saying the CO2 given off is more. When? Slowly, when metal carbonate react with the carboxylic as compared to hydrochloric acid, same concentration. Given off more. Carboxylic acid or weak acid oppose the strong acid such as hydrochloric acid. Here little bit misconcept is there. You will see the practical on the next page. CO2 gas given off more slowly. More slowly. So which case more slowly is there? Can you tell me? CO2 gas given off more slowly when metal carbonate react with carboxylic acid. What are there slowly? Yes or no?
Yes.
As compared with hydrochloric acid with the same concentration. So if you are concentration, you are talking about HCl. So CO2 will be faster or slower in case of HCl?
HCl will be faster.
Understood. So why this is
Yeah,
happening? Because
because it
carboxylic
has a
acid are weak
strong.
and oppose compared to strong acid such as hydrochloric acid. These two concept is okay.
Yeah.
Now the second point they are saying that is a strong acid ionize all. So this is HCl. If you are ionizing, it is 100% ionizing. Now you read out this statement. Can you please read?
We say that strong acids ionize completely in solution. However, in weak acids, most of the molecules stay as they are. Only some will ionize in their solutions. At position of equilibrium is reached in which both molecules and ions are present. So in ethanoic acid, which is the formula,
Hmm. Okay.
ethanoic acid
Giving
is
ethanoate ion and hydrogen ion. Here you will read this one also, please.
therefore given to aqueous solutions of equal concentration. The strong acid will have a higher concentration of H plus ions than the
Hmm.
solution of weak acids. So a weak acid has a higher pH and therefore reacts more slowly with a metal carbonate.
Okay. Now I think you must have understood what is they are saying the total statement. The HCl is strong acid. This is the strong acid. So strong acid means giving more H plus ion. This H plus ion is 100%. And this H plus ion is very less. This is very less. So very less H plus ion means what is going to be weak acid. This is very weak acid. See. So we say that strong acid ionize completely. So this is 100% ionized. Okay. HCl is 100%. If it is the 100% is there, so it is going to give 100% H plus ion plus Cl minus also going to be 100%. So we need to know about this one, H plus ion. Second, however, in weak acid, most of the molecules stay as they are. As they are means they are not going to ionize. See, here the one direction is there, one way, but here is the two ways are there. Okay, it stays the same way. Only some will ionize in their solution position equilibrium. Means equilibrium means both forward and backward reaction are going on. Both molecule, that is ions and present. Means this is there and this also ions are also there. Okay. Now see the second paragraph, what the point they are saying. Therefore, given two equal solution, equal concentration, the strong acid will have higher concentration of H plus ion. So this is having high concentration ion as compared to weak acid. So weak acid has higher pH compared to the strong acid. Are you be able to understand? No.
A little bit.
Okay. See, HCl is there. You know this is the strong acid. Yes or no?
Yes.
Because it giving the faster CO2 gas when it is being treated with the metal carbonate. Yes or no?
Yes.
So if you see, so it is going to ionize what is that is the H plus Cl minus. So this H plus will be more H plus ion, that is strong acid. Understood? Yes
Yes.
or no? Ionize here is what they are saying. Ionize completely. This is going to ionize completely. Why completely ionize? Because it is strong acid. Yes or no?
Yes.
Now see the CH3 COOH, acetic acid. So here you see this is the less ionized. This is going to be less ionized. So what it is going to form CH3 COO minus plus it is going to give the H plus, right? It is less ionized. Yes or no?
Yes.
So H plus ion will be less H plus ion, less H
Yes.
plus ion. So less H plus ion means what it is going to be? It is going to be what? Weak acid.
Weak acid.
Understood?
Yeah. Yes,
Sure,
sir.
no? Okay.
Yes.
So I am erasing this one. Again going back to the your book. So now up to here. Okay. See the practically read out, please, please, please. This one you read.
Comparing ethanoic acid and hydrochloric acid. Write down your observations to compare ethanoic acid with hydrochloric acid of the same concentration. Take a pH of solutions of both acids. Add a little sodium carbonate to solutions of both acids. Why did you use the same concentration of each acid in the experiment?
Hmm.
Same
Septi, where I.
concentration
Hmm.
was used because if different concentration,
Hmm.
so okay, let me phrase this.
Hmm.
Concentration affects the rate
Hmm.
of reaction, and
Hmm.
if they're not taken in the same quantities, it would if there's one, if let's say there is more of hydrochloric acid, then it would be quicker because it would speed up the reaction, which would
Hmm.
not be fair and the test would be incorrect.
Okay, very good, very good, very good. Why? Why? Okay, take the pH of the solution of both sides. So what the pH you will get? Take the pH of solution of both sides. Write down your observation to compare ethanoic acid and hydrochloric acid in the same concentration. Which have pH more and which have less? One is
uh,
HCl and another
HCl
is no, less pH. It is less
why?
pH. Why? That
Oh
is
yeah.
strong acid. Huh.
Oh yeah, yeah. I thought less was that would have more.
No, no, that is concept we should know now. See, seven is the neutral. Seven is the like the water.
Some
This is the
seven.
neutral. More than seven means strong base. SB is strong base, and less than seven is strong acid. So lesser the value of pH, lesser the value of pH, stronger is the acid. Otherwise, it will become the neutral. Now add little sodium carbonate solution of both acid. So what you will observe? What you will observe? If you are adding the sodium carbonate in both HCl and COOH, so which will give the faster CO2?
HCl.
HCl. Very good, very good. Okay, so here is the some. Okay, almost we reached to the end of the chapter. You read this one. Please read. making ester?
Um,
Hmm.
Carboxylic acid reacts with um sorry carbo carboxylic acid is also formed in this reversible reaction. A strong acid, usually sulfuric acid, is used as a catalyst. For example, ethanoic acid plus ethanol
Hmm.
gives ethyl ethanoate plus water.
Hmm.
In general, carboxylic acid plus alcohol
Okay,
gives
better.
ester plus water.
Hmm. Okay, thank you. So let us go on the up here. So making ester, making. So if you talk about ester, so ester formula is C double O C5. This is what is called ethyl ethanoate. 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 Okay. So this is what is the ester. Now if you talk about this, that is what is the common ester, like what the perfume we use are nothing but they are the ester. Okay, perfumes are the ester only. So how you are making the statement, that is acetic acid. You can say ethanoic acid. You are treating ethanol with what you are treating ethyl alcohol. No, ethanol. The ethanol, the presence of what? Concentrated H2SO4. So what you are going to get ester plus water, right? Now let us see the equation. Okay, here you see CH3, C, here is OH plus CH3, CH2OH. Here is what is there? Concentrated H2SO4. So here how the reaction is going to, here you see this H is going to be out with this one. So it is going to be one molecule is water. What is second molecule? You start writing CH3, C double bond O, again O, and it is going to attach with this one. So CH2, CH3, CH2, CH3. This is what is the ester. Are you be able to understand the reaction?
Sir, sort of. I don't get how they like just form water and
If you are adding these two, acetic acid, ethanoic acid and ethanol, it is automatically it is going one.
sir, your voice
And
is
how the
cracking.
reaction is happening, you can see. Oh, now is it? This is the, you see 1 2, and here see AB. So here is the 1 2 AB, how it is attached.
Um,
ए,
it keeps
Asa,
between.
can you disconnect? Yeah, now I'm not able to. It is connected with you. You see, it is 3 devices are showing. Okay. Is it audible?
Yeah, it's
Carney, it's audible to you?
yes.
I think someone else has connected. Hmm. I don't know who is connecting. Okay. So can I erase this one?
Yeah.
There now you can see the same reaction here. Ethanoic acid, ethanol, so it is giving the reaction. Carboxylic acid, no. Carboxylic acid plus alcohol, it is giving ester plus water. Are you be able to understand this reaction? Hello, Tarni? Tarni, is it audible?
Yes, sir. Yeah, yeah, it is. It is.
Okay. So see, one reaction we studied with ethyl alcohol. What we are going to do, we are with methyl alcohol and with ethanoic acid, and second one propanoic acid and ethanol. So you need to show me these reactions. Okay. So esters formed have the distinct smell. They are volatile, evaporate easily. Many smell sweet and fruity. Their smell are sweet and fruity. This makes them ideal to use as a perfume and food, flavoring. So these are the point. Now I am giving you the equations. You just let me know how you understood. So suppose you are taking that is another compound here. You see what the product is forming. You just see CH3 C double O plus CH3OH. Is the concentrated, this is the reversible reaction, both direction it is running. So tell me the name of the product here. I am making you the
CCH.
admin. You no, you write down. I am making you the admin. Wait. Let me check. Where are you? I am making you the admin, and so you can become the teacher. Sorry. Not able to connect the Zoom. Oh, yeah, it came. Sorry. Make host. Where are you? I make you the host. You please start writing. Got it. Oh, okay. Where is this? Yeah. Can you complete this reaction? Yes, Tarni.
Uh, yeah.
Hmm. Hmm. See how I have done the upper one. How I have done this one.
I'm trying.
The same way. Only the change is here.
Sure.
At the place of ethyl alcohol, I have taken methyl alcohol or methanol. Do it.
I can't see. If can you repeat? It was CH
Is
because
it
I can't
visible?
see
The
your
screen is
screen.
visible to you or not?
No,
Acha, you
that's what
became
if
the
I.
admin. That is what the problem.
Yeah, that's what I'm saying.
Oh, hmm, that is the problem. What I can do now? Okay. Any other option are there to share? Can
Sir,
you?
um,
Hmm.
I'll see if I can make you the co-host, and we both can annotate. One second.
Okay. Try it.
No, that's not an option. Okay, I'll make you the host, or do you want me to? Do you want to tell me what the question is?
But the last class you was able to write now. You was only
Yeah, I
writing.
can see your screen. I can type, but I don't know the question.
But last class, I think no need to make you admin. Okay, to make you write, no need to make you admin. Without
That was
being
only
admin, you
whiteboard.
make me the host, please.
Okay,
Please make me host admin, please.
I did. One second. Done.
Okay. Huh. Okay. Screen. Okay. Now is it visible? This must be visible to you. Now, what you do? Just you start writing. You can write on the paper this page. Can you write?
No, I can't write. That's what I'm saying. You need to be on whiteboard for that.
This is the whiteboard only.
No, like Zoom's whiteboard.
Oh, okay. Go. Let me. Mhm. Okay. I'm giving you the questions. Here you see CH3 C double OH plus. It was earlier C2H5OH. So here if you are treating with the concentrated sulfuric acid, this is concentrated H2SO4. So how the reaction was there? Suppose H here and OH here. So what it was giving, that is CH3 COO C2H5 plus it is giving H2O. Now the question they have given in your book, CH3 COOH plus here is you are supposed to take CH3OH. So what is the product you are going to write? That is P plus P dash. You write down this one. This question. What will be their product? And one more reaction, CH3 CH2 COOH plus C2H5OH. So you write down the product here, P plus P dash. Yeah, tell me.
I don't let me write. I can't
Can
see
you
the.
try?
No.
Can you try?
I can try, but it won't let me write. That's the thing.
Okay, okay. Like that, what we have done, Diana, the similar you have to try. Are you trying?
Yeah.
Okay, try.
Um. H3.
Can't you write by tab?
No,
What happened?
it's not letting me write. So I'm doing it in my book, and I'll tell you what I get.
Last day you was able to now.
Yeah, because I was sharing the screen and you were writing.
Uh-huh.
So we would get H2O
Okay.
for sure, which means this
H2O this.
cancelled. So we get CH3COOCH3. That means we have, yeah,
Okay. So you are saying CH3 C double O, then CH3, and here is OH going to be
that's
out.
H2O.
So this is the H2O. What is left here? CH3 C double O, CH3 C double O, and this CH3. And the same way H2O is going to be out here. This is H. Here is OH. This is out. So what is left? CH3, CH2, C double O, C2H5. Are you be able to understand this one?
Yeah.
The same reactions are here you mentioned in your book. Check this reaction. Check this reaction, please. Can you understand this one? Here the reaction number 1. This is 2 and this is 3. Check out.
C2H5COOC2H5 plus H2O.
So can you understand this one? Here is H and this is the OH going to be out. So this compound and this compound. Similarly, here is the H, here is OH. So this compound, here is the H and here is OH. So this compound and this compound. Is it okay?
Yeah.
Now see key point, key point. So key point if you are learning, so key point they are saying solution of carboxylic acid have pH value less than 7. Carbonate gently freeze in their acidic solution, releasing what is carbon dioxide gas. So if you are treating the carboxylic acid, so what the gas you are going to get? Oh, are you be able to see the screen, what I am teaching?
No.
So you should tell na. So
I,
many things.
sir, I was
So many
trying to
things.
figure out.
So many underlined. Oh God. These things I was saying, these 3 equations. See, this is the one, the first one is here, second one, third one. Okay, getting?
Yes.
And here key point, second one, number one going. Aqueous solution of weak acid such as carboxylic acid have pH value higher than the solution of strong acid. with the same concentration. Is this point clear? You read again.
Aqueous solution of weak acids such as carboxylic acid have a higher pH value than solutions of strong acids with some concentration, same concentration.
Is it okay?
Yeah.
Okay. Ester are made by reacting carboxylic acid and alcohol together with the strong acid catalyst, like that H2SO4. So that also. Ester are volatile fragrant compound used in flavoring and the perfumes. So this is also over. Now go for the question number 1. Okay, read the question number 1 and answer me, please.
Which gas is made when propanoic acid reacts with potassium carbonate?
Hmm.
With
Which gas will released?
gas carbon dioxide.
Very good, very good, very good. Intelligent girl. Carbon dioxide. Name of the salt form.
Name okay.
Hmm.
So it's supposed to be me as 1 second. It's going to be potassium
अच्छा, potassium.
propanate.
हाँ, very good, very good, very good. So K2CO3 is there, na? Two molecule you are taking. So what the salt is going to be 2CH3, CH2, C double O K. So potassium propanoate, POTASSIUM, potassium propanoate, PROPANOATE, plus CO2 plus H2O. Is it okay? Is it
Yeah.
okay?
Yeah.
Here they are saying write a balance symbol equation for the reaction. So this I already write. This is the equation symbol for. Is it okay?
Yes, I'm just writing it down.
Okay, okay.
Yeah.
Hmm. Next question, can you tell me?
Write a balanced equation including the catalyst to show the reversible reaction between methanoic acid and ethanol.
So methanoic acid is what? That is HCOOH. And ethanol is what? C2H5OH. So how the reaction takes place? Acid H and this is OH, right? So what will be there? One is the H2O, second one HCOO, then it is going to be C2H5. So this is what is the product, two product. So what is the understood? So there they write the word equation including the word equation also. Methanoic acid plus methanol is equal to here is ethyl methanoate to show the reversible reaction between this one. Can you understand this one?
Yes.
Name the ester formed from ethanoic acid and ethanol. Methanoic acid and propanol. Just we have done just a few minutes before we have done this one, this two one, right? So I'm not telling you that one. Ester are volatile compound. What does this mean? What is meaning of a volatile compound? Yeah, tell me.
Um,
The ester forms they are volatile, means evaporate
Explosive.
easily.
You
Uh,
evaporate easily.
go evaporate easily. This is the what the answer. Now go next one. What they are saying. Give two usage of ester. Can you tell me what are the two usage of ester?
Perfume.
Perfume and flavoring agent. No, you
Yeah,
can read out here.
perfume.
This makes ideal use of perfume and food flavorings, right? Explain in detail why propanoic acid is described as weak acid. Oh my God, this question number 3. Tell me. Why propanoic acid described as weak acid? Tell me. 3 reasons I give you. Because it gives slower CO2
Because
compared to HCl.
it has slower
And
CO2 because it is it has more pH value and it is less
mm,
acidic.
super. You are super. So that is these questions can you do by yourself? These are the question.
Yeah.
Practice question.
Sir,
Chapter
I'll
summary,
finish
please tell.
them by next week. This one and the other chapter.
So then what should I teach you now? This over.
Oh, yeah, we still have 10 minutes.
Hmm.
So should we go
Now
back
hmm.
starting from chapter 5?
Which chapter?
5.
Chapter 5. Okay.
I
Let's
I
go
think
chapter
I
5.
know this, but I just like a quick overview, like not in that depth.
We are giving. I am giving only overview only. I'm not giving depth one
Yeah,
because
because
you know
these
most of the thing. Mhm. Uh, you okay? Okay, this is the 11. No problem. 1 second. Just going. Do you know the page number? Chapter number 5, page number
64 in my book.
64 in your book. Okay, it's reaching. Chapter 9 we have reached. This is the 8, chapter number 8. Chapter number 6. 5.6. 5. Chapter number 5.1. Oh, this is chapter electrolysis. Okay, very good, very good. Very nice chapter. What is lysis? Do you know lysis? Lysis.
No.
Lysis means breaking. Lysis means breaking, right? And electro means electricity. Electricity. So you are breaking any something with the help of what? Electricity. Okay. So if I will write the definition here, electrolysis, here I am writing electrolysis. Okay. So breaking of substance either you write, okay, substance or electrolyte, the better word is electrolyte, breaking of electrolyte. What are the electrolyte? That is, electrolyte means you can say salt, okay, by electricity is called, what it is called, is called electrolysis, is called electrolysis. So what is electrolysis? Breaking of electrolyte by electricity is called electrolysis. Are you be able to understand this one?
Yes.
Okay, now see. Please, if you read, I can explain you much better because you read very nicely. So you read up to here, then I will explain. After learning this chapter, what happen in electrolysis, you will know the type of substance that can be electrolyzed, that will know the product of electrolysis. So 3 things you will be able to know that I will teach. Firstly, you read this all the paragraph. Okay, please, you continue up to here.
Okay.
Hmm.
The word
Hmm.
electrolysis means breaking down using electricity. In electrolysis, an electric current is used to break down an ionic substance. The substance that is broken down by electrolysis is called the electrolyte. To set up an electrical
Hmm.
circuit for electrolysis, there are 2 electrodes which dip into
Hmm.
the electrolyte. The electrodes are
Hmm.
conducting rods. One of these
Hmm.
is connected to the positive terminal of a power supply. The positive
Hmm.
electrode is called the anode, and
Hmm.
uh the other electrode is connected to the negative terminal and is the cathode. The
Hmm.
electrodes are often made up of an unreactive or inert substance.
Hmm.
This is often graphite or something platinum.
Hmm.
This is so the electrodes do not react with the electrolyte or product made in electrolysis. During
Hmm.
electrolysis, positively charged ions move to the cathode,
Hmm.
negative electrode. At the same time, the negative ions move to the anode, which is a positive electrode. When the
Hmm.
ions reach the electrodes, they lose their charges and become elements. Gases may be given off or metals deposited at the electrodes. This depends on the compound uses and whether it is molten dissolved in water.
Hmm. Okay, see the diagram here. This is the diagram. So what you read out, total these things you read. Okay. So what is there? This is the two rod are there. These rod. Okay. These rod are called, that is these two rods are called electrodes. These rod are called electrodes. Okay, metal electrode. The one which is attached with positive, that is what is called anode. The one which is negative terminal, that is called cathode. That you read out. Okay. These both electrode are connected with the battery. Okay. And they are depend into the electrolyte. Now read out the line by line. Firstly, let me draw the diagram so that you can understand a little bit. Okay. So till now we study what we study. This is what the container. That is what is called electrolytic cell. This container, and this is connected with two electrode, metal electrode. Connected with one is connected with positive terminal. This is longer one. Then another is connected with negative terminal, is smaller one. This is what negative terminal is called cathode and positive terminal is called anode. Anode. And here is what is depend in this one. This is what is called electrolyte. This is what the word you are using, electrolyte. Now here you read the word electrolysis means breaking down using electricity. Okay, breaking down by using electrolysis. In electrolysis, an electric current is used to break down the ionic substance. Ionic substance means salt, NaCl. The substance that broken down by electrolysis is called electrolyte. Whatever is going to be broken down, that is called electrolyte. Okay, now to set up the electrical circuit, the electrolysis, there are two electrodes which dip into the electrolyte. Electrolyte means whatever the salt solution. Electrolyte means salt solution. And two electrodes are depend in this one, right? Now, the second point you read here. The electrodes are connecting rod. One of these is connected to the positive terminal power supply. This positive terminal electrode is called anode. So here you see, this is the positive terminal, larger one, that is called anode. And negative terminal is called cathode. Are you be able to understand?
Yes.
The other electrode connected to negative terminal, that is called cathode. The electrodes are often made up of the unreactive inert substance. Okay, these electrodes are not that much reactive. This is often graphite, that is carbon, sometimes platinum. This is so electrode do not react with an electrolyte or the product made in electrolysis. During electrolysis, positive charge ion move to the cathode. So if the in the solution, if you I will say you that is positive charge are the ion are there. So where this positive charge ion opposite charge attract, so this positive charge will go on the negatively charge. Right. This is what the point they are saying. During electrolysis, positive charge ion move toward the cathode, negative electrode. At the same time, the negative ion move to the positive electrode. So if any negative ions are there, this one, so this is going to move this direction. Is it okay?
Yes.
Now, when the ion reach the electrode, they lose their charge and become the element. Gases may be given off the metal deposit electrode. This depends on the compound used. So here you see this one. If you are treating the PBBr2, so it is becoming what? PB and Br2. This is, and you go in here, you can see CuBr2. This is giving the element Cu and Br2. So this is how this is happening. Are you be able to understand up to here?
Yes.
Now you read this demonstration. Read.
1 second.
Hmm.
The electrolysis of molten lead bromide. The
Hmm.
This demonstration needs a fume cupboard because bromine is toxic. When when does the
Hmm.
bulb wait? Because toxic and corrosive. When does the bulb light up? What
Hmm.
is observed at each electrode?
Hmm.
Passing electricity
Hmm.
through molten lead bromine, it forms molten lead and brown bromine gas as electrolyte is broken down by electricity.
Hmm. Safety. Warm asthmatic wear chemicals, is splash-proof eye protection, lead bromine and bromine are toxic. So what they are saying, Tarini, here the chemical are taken now. These are the chemical. These are the electrode. So when you are taking now, this demonstrator need a fume cupboard because bromine is a toxic. So here they are the cup they have taken. When does bulb light up? Here, when you are supplying the electricity, bulb is light up. What is the observed at each electrode? So each electrode there will be reaction. What is happening here? Bromine is getting evaporate. What gas? Brown gas, right? So this is why, this is because when you are passing electricity through molten lead bromide, it forms the molten lead. So it is forming the PB, and bromine gas electrolyte is broken down by electrolysis. So this is the bromine gas is going to be evaporated. This is. So what we will do in the next class, I will explain you much better way because today already you studied that chapter now. So you may find little difficulty. So next class will is teach you electrolysis of solution. Okay.
Okay.
Are you are you, if you want today, I will go continue. I can teach little more.
I actually have to go.
Okay,
Um,
okay. That I can understand. 1 hours continuously watching, that is not easy task. Okay.
mm,
You have too much passion. That is why you are, doing,
mm,
you will be very successful because doing very hard work. Yes,
yeah. Yes.
Okay. Bye, Tarni. Take care.
Bye.
Okay. Bye.
Thank
Bye.
you.
Take care.